Hi guys. So just because today I had a little bit more time, so I'm gonna also like show you how to run a experiment like a nosy experiment with excitation sculpting, for example. Actually you can use like multiple pulse sequence that has like water suppression. Um, and actually if you have a look at my video that shows how to use water how to run experiments with water suppression, you can pretty much use the same parameters in this experiment. So here I just calibrate the pulse. So I'm gonna use exactly the same pulse, which is 7.91. But what I'm gonna load here is an experiment. So one thing is if you come here on nosy and then if we like yes, like this, so it's gonna show like some like two pulse sequence. We can get this one, like it's a nose pulse sequence with excitation sculpting, gradient pulse, and it's phase sensitive. So we can come here and we can load it, experiment two. And then first thing we can do is like get Prozol. One thing is, so if I get Prozol, just like this, so I have just like the pulses like that are saved in my Prozol table. So remember that I calibrated this pulse P1, so I can just get Prozol 1H, so it's the hydrogen. I calibrated 9T. And then the power, the power level for the hard pulse is minus 11.48 for this probe. And then this will just be updated over here. One important thing, same as for the, I mean, whenever water suppression pulse sequence you're using, unless you have the frequency like changing when you're applying a certain pulse, like you're gonna put your offset in the water, which is like 4.7 in this case. All the gradients are okay. Of course that I would just like set my RG to the maximum. So if it is like and then I'll check if that's okay or not, or if I have like any sort of are like ADC overflow or something. I would just drop this guy to one. So just say and then I have a small molecule, so I will use a mixing time of like I don't know, I can use like 800 millisecond, for example. So if we run like a GS and check our water, so it looks kind of actually looks fine. Looks okay. We can also have a look here. And then we can just like yeah, click here. And then looks kind of fine. And then we can like save and stop. So we can use that. And then we can check our SW. It's fine too, like for this sample. And if you want to use like a longer D1, just to give your samples a little bit more time to relax, then pay attention in the minimal number of scans. And also pay attention that the number of scans must be like a multiple of 8 because of your phase cycling. And the minimum, like the DS, like 16 or higher than that. Okay. This is like when you run, like for example, I'm gonna just like for like some random number here. Okay. When you run this command here, get Prozol, then the nucleides, hydrogen, and then the pulse that is 7.92 microseconds, and then the power, okay, of the is the power level for the for the hard pulse. That is my for and remember that for you have to, if you want to check what it is on your probe, just get Prozol, and then you can just read on the side that's going to show that. And then when you get Prozol here using this command, and then the power the shaped pulse is going to be like automatically calibrated, will be like automatically calibrated like the power level. Okay. And then that's it. Like you can set the number of increments. It depends here. It will depend on how crowded is your spectrum. If you have like a lot of hydrogen close to each other, you need like more increments in the indirect dimension, because then you want to have like more um more like resolution. And that's it. You can just, for now, like you can just like ZG. Then we can check the first. I always check, for example, I like to check, for example, the first increment, and also um, a few other, when I have like a few increments, like 3, 4, something like that, just to see if everything looks good like, in terms of phase. Um, but in general, most of the experiments you can actually um, have that information on the first, like on the first increment. Um, and if you're running a cozy, um, I mean, you can again choose either excitation sculpting. You can use like we can use like Watergate or preset. So it's pretty much the same the way we load. You can use those like the asterisk on the name, so you can filter out like some stuff that you don't want and just leave the ones that you want. Okay, so that's it. Just gonna show you that the first scan actually looks okay. So yeah, so the water is being suppressed, and I'm pretty close to my 0 ppm over here. Like I could have left like a little bit like more space here, because I'm my offset is centered to 4.7, so I have like some empty space here. But when I'm processing my data, I could just like use this sweep with it. And then you can just go to the first one and XFB, for example. And then we can actually check if there is any specific requests for phases at the end of the post sequence. For example, this one is 90 minus 180 and the F core equal 1. So we can just check if everything looks okay over here. It should, yeah, everything looks fine. And then how I can actually do something like, sorry, APK2D. It's a way of processing, for example. And then to do like a more, I like a better phase. You can also like, yeah, I'm pretty close to the edges here. So I should put like a little bit, make my sweep width a little bit like wider instead of, yeah, but I think it's fine. And then, yep, signal starting to show up. And that's as a small molecule, so I should I'll see like probably like if the viscosity is not really high, I'll observe like the diagonal peaks and the cross peaks with like different like with different phase, like so as you can see here, like it's showing as negative, for example, and diagonal showing as positive. So I don't have enough resolution yet, and I don't want to use linear prediction here because it's too earlier for that. So it's too early for that. So yeah, that's pretty much it. And yeah, I hope you enjoy the video.